Hi, everybody. So we are going to finish up part 4 by solving a system of nonlinear system algebraically. So we already know what the answer is in Desmos, right? We can see the intersection. We can click on the intersection in Desmos to see what the solution is, right? What we're going to do is actually solve the equation algebraically. So with that said, let's go ahead and take a look at our function. Now, here's the catch, okay? And I'm saying this now, but I will definitely say it in class beforehand that when you are choosing your function, you need to be strategic about what you're intersecting it with, since you know you're going to have to solve a system, right? Miss Lawrence didn't really get made hers kind of difficult. So all the equations that are actually intersecting are quite, difficult to solve. So I wouldn't do it in this class now too. We would do this in an upper level math class and when we're solving those type of equations. So let's look for an equation that actually on in math 2 we can solve. So it could be a quadratic linear equation, it could be a radical linear equation, it could be a rational linear equation. So it could be a linear equation matched with any other of the other nonlinear functions. Okay, but you don't want to do two nonlinear functions um, to in this project. Okay, so make it simple. You know, make it simple because you're solving a system. So let me tell you what I chose. All right, the system that I chose. So I had two options, right? I had the K's here, right? I saw that the K and the linear they were intersecting, but I thought that would be too easy, right? So I didn't do that one. Um, but I do see, and so that was a quadratic that was intersecting with a linear. So we can look at that. So that's a quadratic intersecting with a linear function. So I could solve that, all right, and that would work out just fine. I could also do these y's, right? So let's look at the y. I can also do the y. Let me turn off the e and the n and the a. So I said look at the y's because it looks like it's two quadratics intersecting, okay? So the two quadratics are, it looks like that one and yeah, that one. Hold on, let's put that one back on. Is it this one? Yeah. All right. So it looks like it's just those two intersecting right here. So that's what we're going to use. I am going to solve this system. I didn't want to go for the easy one because then you'll be like, oh, it's not like mine. So I wanted to go for the harder one so I could show you how to solve that one. But if you want to go for the easier one, feel free. Go ahead. It's your world. Okay. All right. So let's go ahead and get started. So the first thing we want to do is verify the solution. Let's go ahead and click on the intersection in Desmos. That's the nice part about Desmos. We can click on the intersection and we see that our solution here is going to be 12.83, 7.014. That is the point of intersection. Therefore, that is our solution to our system. Okay. So we're going to now verify that algebraically. So when we're solving systems, we're going to go ahead and set this equation equal to this equation. So we have 7 over 3 times x minus 11 squared minus 0.8 is equal to 0.9 times x minus 11 squared plus 4. Okay. Now, hmm, let's see. Where do we even begin? Let's first go ahead and try to get the expressions, solo, an expression solo. So I'm going to add 0.8 to both sides to balance the equation. All right. So that's 7/3 x minus 11 squared. The negative and the positive of 0.8 cancel out, 0.9 x minus 11 squared plus 4.8 is what I have. Okay, so now, okay, woo, what do I do? Okay, so I can actually multiply this out, the squared term right here, the expressions. I can do that, right? But here's the deal. if you saw 4x, right, and you saw 5x, you would simply just say 4 minus 5 and then x, because you would factor out that x, right? That was a common term between both of them. So that would give you negative 1x. Well, that's exactly what I'm going to do about this one, okay? I'm going to actually move this over. And because they share this x minus 11 squared, both of them, these are like terms. So I'm just going to move it over. I'm just going to do the opposite. So the opposite of 0.9 is negative 0.9. X minus 11 squared minus 0.9. X minus 11 squared. Okay. And then I'm going to bring down the 4.8. All right. This cancels. All right. Because one is positive, one is negative. So that cancels. And so now I am going to combine like terms. So I bring down the x minus 11 squared. And what I need to do now is combine these two terms here, the 7/3 and then negative 0.9. So I'm going to go back to decimals for that. All right, so we're ready to do it. 7/3 minus, oops, let's not put that in the denominator, minus 0.9. And that gives me 1.43333 repeating. So 1.43 repeating is what I have here. And I'm just going to repeating symbol over it right there. Okay, so now remember, to solve this quadratic, we would go ahead and isolate the parenthesis here. So I'm going to divide both sides by 1.43 repeating. Okay. And so I end up with x minus 11 squared is equal to 4.8 divided by 1.43 repeating. So let's go ahead and figure out what that is. Okay, so I'm going to make it so that I, right, don't have to, I'm not rounding, right? So I'm going to just type in this whole expression up here, 1.43 repeating, and I'm going to type in a couple of threes so I can keep it as accurate as possible. Okay, and that gives me like a 3.348, and I'm going to do it to 4 decimal places. So 3.3488, 3.3488, 3.3488, 3.3488. Okay, so now to solve this, I'm going to take the square root of both sides to undo this power 2. So whenever you're trying to solve a radical, I mean, it's not a radical, but a power function, you always do the same index as the power. All right, so whatever you do on one side, you must do on the other. All right, so we end up with x minus 11 is equal to plus or minus whatever this decimal is, 3.3488, right? And then finally, we're going to add 11 to both sides. So x is equal to 11 plus or minus square root of 3.3488. Now, let's look at which one is a solution. So x is equal to 11 plus the square root of 3.3488, or x is equal to 11 minus the square root of 3.3488. So remember, the solution that we're trying to verify is 12.83 and 7.014. That's what we're trying to verify. Okay, so let's go back to Desmos and let's type this expression in and see if that gives us our next answer. Okay, so here we are in Desmos, and we're typing in the expression 3.488. All right, and there it goes. That 12.82. Now we're not finished. That's just the x coordinate. So now we have to take this number and plug it back into the function to see what we're going to get. So here I am, and I'm verifying that this is the answer. So I got 12.83 from my Desmos. Okay. I did not go ahead and solve this one just because this is not the one that I'm verifying, right? This is the one that I'm verifying. So I'm just going to continue to work with this one. So I'm going to take that number and I'm going to plug it back into the function. It doesn't matter which function that I plug it back into, because remember, for both of them, it's the same. So I can always choose whichever function I think is the easiest. I think dealing with the decimal is easier than dealing with the fraction, even though it doesn't matter. So let's see. We got 0.9 times x minus 11 squared plus 4. So 0.9 times x minus 11 squared plus 4. And we're going to plug the number 12.83 into that function. So y is equal to 0.9, 12.83 minus 11 squared plus 4. And we're checking to see if that's going to give us 7.014. So we're going to take this function, this expression, and we're going to plug it into Desmos as our calculator. So here I am in Desmos typing in the function 0.9 times 12.83 minus 11 squared plus 4. And voila, it gave me 7.014, which is my solution. Therefore, I have solved and verified the system. Okay. So now what you're going to do is, after you do that, you're going to take a picture of your work and submit it. So I am going to take a picture of this and submit it. Oops. 7.014. Check, check, check. That's the answer.